Okay, this lesson is 4.2, Special Properties of Kites and Trapezoids. And this is mainly review. We have filled in the chart and already reviewed these properties. We're just going to get them down formally. So first of all, if we know we have a kite, we get the following properties. And if we remember, our definition of a kite is that we have two pair consecutive equal sides. What do we get in addition? We get perpendicular diagonals. We get one pair opposite angles equal. We get vertex angles bisected. And we get one diagonal bisected. And if we look over in the picture, you can see these things happening. The vertex angles, perpendicular diagonals, meet right here, everybody 90 degrees. One pair of opposite angles equal. And those angles that are opposite are where the non-equal sides join up. Vertex angles, this and this, are vertex angles, where the two equal sides meet. And the diagonal is bisected on the equal sides. Now, if you have trouble remembering this, think about folding a kite in half with that line of symmetry where everything matches up, and that helps you keep all of these properties straight. Now, you guys know how I love fill in the blank pictures. And if I work just initially from this picture, here's a vertex angle, so I know it gets bisected, 80 and 80. That means the big angle is 160. Vertex angle down here, 28, 28. Big angle is 56. My whole diagonal is 8.2. That means that each piece is 4.1. My 90 degrees here. Now, I can find these smaller angles by either using triangle sum and know that x plus 90 plus 80 is equal to 180. X plus 170 is equal to 180. X equals 10. And I can turn around and I can do the same thing for this bottom angle right here. I call this y. This is also a right angle. I could do y plus 90 plus 28 is equal to 180. Y plus 118 is equal to 180. Subtract 118. Y is equal to 62. So that means this is 62, that is 62, this is 10, and this one is 10. The other thing that happens in a kite is the top and bottom halves form isosceles triangles. And so always remember you have those isosceles triangles. So then, now that my picture's filled in, when I go to answer my questions, KIC is 80 degrees. KIT is the big angle. Add the two pieces is 160. CET is one of the bottom angles. It is 28. KET is the entire vertex angle, which is 56. KCI is one of my 90-degree angles. CT is half of my diagonal. And KT is my entire diagonal, which is 8.2. So once your picture is filled in, the rest of the picture answers fall into play. Now for H, I'm going to have to draw out something separate. If KI is 12, what is IC right here? Now to see this better, I'm going to draw myself a triangle. And I'm going to pull out that upper quadrant. And I know that as half the diagonal, this is 4.1, and this is 12. And since it is a right triangle, I know the Pythagorean theorem applies. And when I work that out, A ends up being 11.3. So square all the numbers, subtract square root. Remember, you get 4 right triangles in a kite, so that Pythagorean theorem definitely applies. Now, properties of a trapezoid. If you know you have an isosceles trapezoid, you get certain properties. What are we talking about definition? Definition, we're talking about a trapezoid. You have to know you have a trapezoid first that has equal legs. And remember, those legs are the non-parallel sides. And we have three things that are true. We get all the trapezoid properties. Go back in your notes and check those out. We get that the base angles are equal and that the diagonals are congruent. So if my picture's marked from the trapezoid, we get our parallel sides. Isosceles, by definition, equal sides. Remember, those base angles are where the legs meet the parallel sides, and the diagonals are congruent. We know nothing about how they intersect the angles. We know nothing how they intersect each other. We just know that from corner to corner, their lengths are the same. Now, quick and easy example. Given an isosceles trapezoid with A being 124, parallel, parallel, equal, equal. If this is 124 by base angles, this is 124. Since it's a trapezoid, we know that same side interior are supplemental. So we know that this one is 56. Its base angle is over here, also 56. Now the trapezoid mid-segment is something that should sound familiar. If you remember go back a couple of units, we had a triangle mid-segment, and we knew that it connected the midpoints, see the equal segments, of the opposite sides of a triangle. We knew it was parallel to the base, and we knew it was half as long as the base. All of those things should sound surprisingly similar when we look at what a trapezoid mid-segment does. It's connecting the midpoints of the legs, so you can see in the pictures. That's the definition. The theorem gives us parallel to the basis, so all three of these guys are parallel, and the length of the mid-segment is 1/2 the sum of the bases. So the mid-segment here, M, is equal to the average, essentially, of the bases. And that should feel very common sense. Now, in looking at an example, mid-segment here, that's equal to 1/2 the sum of the top and the bottom. So 1/2 of 28, it equals 14. Nicely between the top and the bottom numbers. Now this one may look initially a little more complicated, but it's not. Start with what we know. Mid-segment is equal to 1/2 the sum of the bases, which is 10 plus 2x. Now solve for x. Multiplying by 1/2, easiest way to get rid of that. Multiply everything by 2. Subtract 10 from both sides. Divide by 2. And we'll just leave it to figure that Mrs. Green would, of course, make the picture backwards. But the math is still the same, even if, go figure, the picture lies. Good luck with the homework, and